Okay, the first video showed the pump system of the heart, which is just the mechanical pumping that moves blood around the body. To do so, it has to have the electrical conduction system to tell those cells to squeeze. And so it's really important, it's really relevant to Cooey's health, to pacemaker and the defibrillator and her heart failure. So if we have the heart again in the four chambers of the heart, it just happens that this is where these cells lie. But the initial impulse for each pump of the heart originates, if all is healthy and normal, in the SA node. The names don't really matter so much, but the SA node is in the right upper chamber. It's kind of like the general who is telling then all the little foot soldiers what to do, or some version of that. So what the SA node does is each time the heart wants to pump, it will send an impulse that travels down to the next node of electrical cells in between the chambers called the AV node, which is the atrioventricular node. And that travels down the septum between the two left ventricles called the bundle of His. It splits into the left and right bundle branch. Names don't matter so much, sorry. And then come up what's called the Purkinje fibers, which are in the bottom big chambers. So realize when the blood actually gets pumped out, the aorta and the other tubes actually travel up and around. This isn't an anatomically correct picture. And so what that allows is the impulse travels down through, and then as the electrical conduction system sends the impulse to the muscle cells, it actually causes from the heart like this a ringing motion of the muscles. And if you see the heart pump, it's pumping from the bottom up and shoving the blood out the tubes, out to the body and out to the lungs from the right side, which is what we talked about last time. If the SA node fails, which it does, then the next group down the pathway will take over and tell the rest of them what to do. And the more failure you have along this system, the closer we're getting essentially to death and the heart not pumping, and cardiac arrest, which means that the heart stopped. So when we look at an EKG, this would be of a normal EKG on the top. These are just looking at stickers from the body that are showing us what is actually occurring electrically in the heart. This could all be going on, but it not be working correctly and actually pumping the heart. It's just saying what's going on electrically. But if it's acting normally and it goes from SA node to AV node, down the bundles, and then up the Purkinje fibers, that is a depolarization of cells, and that causes an electrical blurb when we're measuring it. This first little wave here is actually then the SA node depolarizing, and then this big one's the important, well, they're all important, but this one's called the QRS. So QRS, and that is when the actual ventricles are depolarizing, and that corresponds with the actual like squeeze of the heart. And then there's a bump at the bottom called the P wave, sorry, T wave, sorry. So the T wave then is actually the heart repolarizing. So P, Q, R, S, T. I'm over explaining it, doesn't really matter. But that means that all of this is working correctly. What happens then with why a person gets a pacemaker is that this guy is the pacemaker and it loses its ability to do so. And so now the impulse for all of this to occur and to cause this to pump is just coming from all over these different cells. And so then people often get what's called atrial fibrillation. Fibrillation is a word that refers to a chaotic rhythm of cells going off. And so atrial fibrillation is that the impulse isn't coming from where it's supposed to be, and so you end up getting just cells just firing off as they can. And the hallmark of atrial fibrillation is an irregular heart rate. And irregular heart rate can cause blood to be pooling in the atrium, and that can cause a blood clot to form, and that's why people on atrial fibrillation end up on Coumadin or blood thinners. Because if a clot does form in there, and then it gets pumped through the ventricles, and let's say on the left side it gets pumped out to the body, well, it's actually going to get pumped first. A little system, a little artery it can go to is up into the brain, and that can cause a stroke, so we can't have that, so they're on blood thinners. If all of this fails and it's no longer atrial fibrillation and it's now in these, and it's called ventricular fibrillation, that's just a chaotic rhythm of cells going off, and that ventricular fibrillation is corresponds with no pulse. You cannot produce a pulse when you're in that, but there's still electricity going off. And that's what a defibrillator is for. That shocks those cells that are firing off chaotically, and then it'll allow the SA node or an internal pacemaker to take back over and redo this. And that's good. And so Cooey has a pacemaker now, which is doing the work of this, keeping some version of that going for her heart to be pumping. She also has an internal defibrillator, which is when this goes into a chaotic rhythm, it will shock it and then allow the electrical conduction system to go back to normal as long as it works. And that's the time that she passed out at the house. That's what happened, and that's why it was a really big deal. But a lot of people have these. They work all the time. It's really common. That was probably over-explained, but yeah. Okay, on to the lungs.